Hi, I'm Dr. Robin Bond, and what I'm going to show you today is an example of how you can do labs remotely. Yeah, I know it's never quite the same as having the students actually in lab, but you can still give them a good quality experience. A quick background on this particular lab: we were supposed to be starting in-person labs this week, as of when I'm recording this. And then we had to postpone opening a week. So this lab was one that they were supposed to do in person, and then I had to adapt it to be remote because we pushed off our opening by a week. So this particular lab, this Chemiluminescence Lab, is one where students try out the scientific method, basically saying, here's what we want to do, here's how we think we can accomplish it, let's test it. And then they look at the results and say, okay, that didn't work. What can we do instead? Or, that kind of worked. How can we optimize it? So what I basically did was I was there. I called myself a robot surgeon that they were operating remotely. They came up with ideas of what they wanted to test, and I was testing for them. So here's how I set myself up for that. Hooked up to my computer, I have a webcam. So at the beginning of the session, I'm actually using the webcam that's built into my computer, but I have an external webcam, which I set up on my little hiking tripod and focused in on the area where I was doing the experiment, and I can switch back and forth between them. Let me show you what we did. By the way, if you're interested in using this protocol, I've dropped a link to it down below. It's on my institutional website. I have edited this video to remove any identifying information on students, so you can't hear their voices or whatever. A lot of this stuff, though, went on in the Zoom chat, and so that's really important that you should know that almost everything went on in the Zoom chat of them telling me what they wanted me to do.
We've got 6 different reagents, and what I'm going to do is I'm going to test all the possible combinations of 2 in those 6 different reagents, which, by the way, is a lot. So you all have the list, and pick one. Let's pick one. In the A thing, the first few cells, I'm gonna do 2 drops of luminol in each cell, and then I'm gonna drop 2 drops of whatever. Okay, so that is the luminol, and now I'm gonna add them one at a time. Okay, so here's the HCl. Here's the NaOH. Here's the bleach. Here's the hydrogen peroxide. Okay, and then DMSO.
So we continued testing combinations of reagents until the students had a good idea of how things reacted with each other.
We're going to be putting in 3 things. Do you think it matters what order I add those 3 things? Yeah, you can vote yes or no on Zoom. Do you know how to do that? Okay, I've got 7-2. Okay, so I think the overwhelming majority is that that order matters, but overwhelming majorities are not always right. So let's do this a scientific way and test. So let's pick a set of 3, and we'll test all the different options as far as what goes in first. Okay? Luminol, bleach, and hydrogen peroxide. Okay, so I'm going to start with the order that we just said: luminol, bleach, and hydrogen peroxide. And then I'm going to do luminol, hydrogen peroxide, and bleach. And then I'm going to do bleach, hydrogen peroxide, and luminol. Okay, luminol. That's luminol. And then this is bleach. 1, 2, 3. And this is hydrogen peroxide. And I'm doing 3 drops. Okay. So that's the first one. Now we're going to do luminol, hydrogen peroxide, and bleach. The next one, we're going to do hydrogen peroxide, bleach, and luminol. What do we do next? We've tested these 3 in a variety of configurations. Why don't we try, if you were going to try something else, what would you try?
So we continue to test different combinations of reagents as recommended by the students, and then they would keep modifying. Different people were suggesting different sorts of combinations. They weren't necessarily all building on each other. Next, we started testing the proportions of the reagents. And again, different sets of students were using different sets of reagents, so it wasn't necessarily building on whoever called in a set of reagents before. But anyone could throw out a recipe, so to speak, and I would test it for them.
So what are we doing here? The students are dropping their recipes for the chemiluminescence thing into the chat. And what's happening, it took us a while to figure out the most efficient way to do this. I have a science instructional technician, SIT, what we call here, but basically they are the ones who pull together the labs and are the instructional technicians for all of our lab classes. So I have an SIT working with me. He is the one who set up all of the materials. And so when the students' recipes came in, at first he was putting them all together, 6 feet apart from me, and then we'd, have a drop-off point halfway in between us where he would put them over and then I would pick them up. And then that went really slowly. So the second round of tests, what we did was I had a couple of the reagents and he had the rest of the reagents, and so I was measuring half and he was measuring half, basically. That also had its own problems, but it went a lot faster, and so we were able to keep up a fairly steady stream of things to show the students.
If your group has agreed on something, please drop it in the chat. So I'm going to get a whole bunch of recipes at once, but Paul's going to help me mix stuff up. You have to give us actual numbers of mils in an amount that is under 10 mils total, because that's what's going to fit in our thing. So we're starting with DMSO. Then we have hydrogen peroxide. And then we have, oh, I got to be careful adding this stuff. Bleach. And then we have luminol. DMSO. DMSO bleach, hydrogen peroxide. One thing you can't tell over Zoom is when I added the bleach to the DMSO, it is hot. The whole thing, the test tube is just heating up. Here's the luminol. Oops. That was not very much. Not very much blue.
We popped the students back into breakout rooms, let them decide how they were going to tweak their recipes, and came back for round 2. Overall, students definitely improved for the round 2, as you will see. But while we watch that, I just want to talk about a few lessons learned. So, first of all, anytime you're on Zoom, there are people who prefer to sit back and be spectators, and it really helps the students to be engaged if you actively try to involve them. That's true in lecture as well as lab. But in this case, there were definitely a few people who were putting forth lots of suggestions for combinations early on, and I had to just say, here are the people I haven't gotten combinations from yet. Things changed once we got them in breakout groups. I think I should have put them in breakout groups earlier on, because everyone became much more involved in the outcome once they'd been in their little breakout groups to determine the initial recipe. So we're now doing in-person labs, and what I've done is I've assigned everyone a virtual lab partner. Even though they can't be close to each other, they communicate with each other over Zoom while they're in lab, and so when we're doing an unknown lab, the virtual lab partners each have the same unknown, even though they can't split the work, like they can't each do half of the pipetting. At least they can bounce ideas off of each other, which I think is the real benefit to having lab partners.
I thought it went pretty well for our first try, and if we end up going back on lockdown, now I have an idea of what we can do. So I hope this was helpful. Let me know if you want to hear more about labs in social distancing protocols.